In this video, we're going to look at a Bayes' theorem example. And this is it. The apple juice factory found that there was a breakdown in the pasteurizing system. Last month, not all the bottles they shipped were pasteurized. And of the bottles shipped, 50% contained juice from Jones Farm. 5% of the bottles contained juice from Benson's farm, and 45% of the bottles contain juice from Martin's farm. So I'll give you a second to write that down. Also, 10% of the bottles with Jones's apple juice, 30% of the bottles with Benson's apple juice, 15% of the bottles with Martin's apple juice were not pasteurized. Finally, apples from Jones's farm and apples from Martin's farm did not contain harmful bacteria. That should have been bacteria. However, the apples from Benson's farm did contain harmful bacteria. So you served a bottle of apple juice to your family and later found that the juice was not pasteurized. What is the probability that the juice came from Jones's farm? What's the probability that the juice came from Benson's farm? What's the probability that the juice came from Martin's farm? And of course, you're mainly concerned. You want to know what the probability is that it came from Benson's farm, because that was the one that had apples that contained harmful bacteria. So this kind of problem is a Bayes' theorem problem. And so let's take a look at this. Now, what we're going to do, of course, we're going to mainly be using this equation here that we talked about previously, where we're going to have maybe like say, what's the probability that it came from Jones's farm, given that it was not pasteurized? So see, that's what we have here. You found that the juice was not pasteurized, so you wanted to know, given that the juice was not pasteurized, what the probability came from Jones's farm? What's the probability that came from Benson's farm or Martin's farm? So that's what we're mainly going to do, is take a look at that. We'll have to start giving some things names. NP is not pasteurized. J is going to mean it's from Jones's farm. We'll call B that's from Benson's farm. And finally, M is this from Martin's farm. So now we know some information, and sometimes when you're doing these problems, maybe it's helpful to organize the data. It's be a little bit easier to work with. So, for example, we know the probability that came from Jones's farm is going to be 50%, because 50% of the bottles contain juice from Jones's farm. And then the probability that came from Benson's farm is 0.05 because only 5% of the bottles were from Benson's farm. And finally, 45% of the bottles were from Martin's farm. So now we know some other information. We know that the 10% of the bottles with Jones's juice were not pasteurized. 30% of the bottles with Benson's juice was not pasteurized, and 15% of the bottles with Martin's juice was not pasteurized. So we have the probability that it's not pasteurized, given that it came from, say, Jones's farm, is 0.10. And now notice I sort of organized this way. I put Jones over here, probably not pasteurized, came from Jones here. Just it's sort of helpful to organize that way. Same thing, the next one would be probability that it's not pasteurized, given it came from Benson's farm. We're told that's 30% or 0.3. Finally, the probability that it's not pasteurized, given that it came from Martin's farm, is going to be 0.15. Now we can calculate our base. So first one, we know what's the probability that it came from Jones's farm. So again, right now we need to know probability. Now we know it's not pasteurized. So given it's not pasteurized, which probably it came from Jones's farm. And again, we can use our base theorem, which says, whatever we have here, that first one is going to be a probability of that times the probability of this reversed. So in this case, it's going to be probability of Jones that came from Jones's times the probability of conditional probability of these two reversed. And then remember the denominator, it's just all of these, probability of A1, probably EA1, etc. So in our case, it's going to be probability of Jones times probability of not pasteurized, given it came from Jones, probability Benson times probability not pasteurized, given it came from Benson. Finally, the probability Martin, probability not pasteurized, it came from Martin. So again, see, when they're organized this way, we can just take this times that. Times this over here. And then for the denominator, we can just multiply these out and add them together. So that's what we have here. Probably Jones times probably not pasteurized, given it came from Jones. Probably a Benson, probably of not pasteurized, given it came from Benson, and so on and so forth. And if we multiply these out, this is going to be 0.0325. Excuse me, 0.1325 or 0.3774. So there's a 37% chance that that unpasteurized bottle came from Jones's apples. Now for part B, it wants to know what the probability that it came from Benson's. And that's actually the most critical one. But now keep in mind, when we do all of the other ones, the denominator is going to be the same. So we can just use the same denominator. We've found that the denominator is 0.1325. We can just use that. So for B, probability it came from Benson, given it's not pasteurized. Remember the numerator is this. And just as first time, I'll rewrite the denominator again. But remember, it's going to be the same. Sorry about that. So yeah, so for part B, what the probability it came from Benson's farm, given that it was not pasteurized. And so once again, at the top, we're going to have 0.05 times 0.30. And again, like I said, we already calculated the denominator, which was the same. And that's going to be 0.1132. And this is the most critical one. So there's a like 11.3% chance that it came from Benson's farm. That was the most critical one because that's the one that had apples that had harmful bacteria. Finally, for part C, probably it came from Martin's farm, given it was not pasteurized. And remember, the denominator is the same. So 51% chance it came from Martin's farm. But again, the one that had harmful bacteria, the apples that had harmful bacteria were the apples from Benson's farm. And there was, so that unpasteurized bottle that you had, there's 11.3% chance that it contained apples from Benson's farm.